Alrighty, welcome back, geometry folks. Now we are going to get to vertical angles. These are the last vocabulary terms that we're going to get to as far as angle measurements are concerned. Yeah, I mean we made it. All that's left is the review and the assessment, and we should be set to go. However, can't look past vertical angles. Now, we've got complementary angles, we've got supplementary angles, then we went to corresponding angles and alternate interior angles. Now, corresponding, alternate interior, also alternating exterior angles, these are all ways of spotting congruence. These are all ways of basically saying, oh, relative to this position, if it's in this position, if this angle is in this position, then that angle has to equal that angle because of X, Y, Z. The issue, though, is that alternate interior, corresponding, and anyway, alternate interior, alternate exterior, and corresponding angles, they all rely on one key detail, and it is that you have two parallel lines with a traversal. You can have, and that's in order to have them be equal. Now you can have lines that are probably going to intersect. And the thing is that all of those definitions apply. This angle here has a corresponding angle here because this angle is on the southwest corner of the traversal as it goes to this first line. Then as it goes to the second line, it's on the southwest corner as well. The issue is that even though these are corresponding angles, they are not equal because these two lines aren't parallel. By the same token, you have the alternate interior angle to this angle here. Its alternate interior counterpart is going to be here. Problem here, because they aren't parallel, those aren't equal. I mean, these are alternate interior angles, but they aren't equal. The definitions themselves are positional, but their congruence is conditional on the fact that these two lines are parallel. So if the two lines aren't parallel, you can still have alternate interior, corresponding, alternate exterior. You can still have all of those, but they will not be equal. They will not be reliably equal. You can't say that they're equal unless you have a bunch of extra information. There is, however, a set of lines that will always be equal to each other. And they are the vertical lines. So what is a vertical line? A vertical line, vertical angles. So what is a vertical angle? A vertical angle, well, two vertical angles, because again, they're pairs. Vertical angles are formed when two lines intersect. What makes a vertical angle are two angles that share the same vertex, so they share the same intersection, but they don't share a side. So these two are vertical angles. It doesn't matter whether they're part of a set of parallel lines, set of complementary lines, set of supplementary lines, that doesn't matter. If you have two lines that intersect and form angles like this, those angles are always going to be equal. You don't need the parallel lines in order for these two to be equal. So, let's run through some really quick examples. Let's take a look here. We've got angle B is equal to 142, 38. All right. So again, this probably isn't going to take very long on the worksheets, but I've got two lines forming an intersection. I've got angle B on this vertex. Now, angle B shares a side with angle A, so I can't do anything about that. Angle B shares a side with angle C. I mean, if I know one of them, I can find the other for supplementary angles, but I really can't say anything else aside from that, right? But angle B does not share a side with angle D, but it does share a vertex. That means that angle B and angle D are going to be equal to one another. So B is 142, that means that D is 142. By the same token, A shares a side with D, so that's not vertical angle. A shares a side with B, so that's not the vertical angle. A shares a vertex with C, but but no sides. Therefore, A and C are always going to be equal, and that's vertical lines. I mean, I wish it was a little bit more complicated than that, but I mean, regardless of what I put up here, if I say this is 32, if I say that this one is 32, and this one is 148, I mean, again, A is 32. A shares a side with B, can't be vertical angles. Shares a side with D, can't be vertical angles. Shares a vertex with C, vertical angles, so 32. And B shares a vertex with D, vertical angles, 148. I mean, it really is that straightforward. It really is that simple. These are the only sets of angles that you can count on to always be congruent. They will always be equal to one another. The key thing that you need to watch out for, however, is if you have a drawing that's something like this, and you just have an intersection, you do not have vertical angles. You have to have two lines crossing that follow through in order to get vertical angles. So if you have anything that is not two lines, two uninterrupted, straight, continuous lines that are intersecting at a point, you do not have vertical angles. And if you don't have vertical angles, they are not equal to one another. So something like this, there are no two straight lines intersecting one another. Now you can make the argument that this is a straight line, but it's intersecting with two others that are not. So you can't get any vertical lines out of this. So if you can't get any vertical lines out of it, then you can't get congruence off of that. So yeah. The thing is, I can even try to jazz this up. I can even add some of these. So let's say A is equal to 60 and D is equal to 120. All right, A is 60. Don't get ahead of me. Don't do B and C yet. But B is equal to 3x and C is equal to 4y. I mean, even if I try to jazz it up a little bit, it's really, I mean, B is a vertical angle to D because it shares a vertex, and not just because I've been using the same drawing over and over again, but because it shares a vertex with D, so 120. Same thing with A and C, not just because I've been using the same drawing, but because these are two intersecting lines at a vertex. A and C share the vertex but no side, so that's 60. 4y equals 60, so y equals 15. Excuse me. Sorry about that. I think the place is haunted. So 4y equals 60, so y equals 15. And if I want to try to get x, I mean x, because it's a vertical line to D, it's 120, so 3x equals 120. X equals 40. I mean, again, kind of like with the corresponding angles and the alternate interior angles, these are positional angles, which means unlike those two, they don't have any kind of conditions with parallel lines and traversals. But because they're positional equalities, because they are equal simply by virtue of where they are on the drawing, there's really not a way to make this any more difficult. There really isn't a way to jazz this up in order to make it more challenging per se. So yeah, I mean, I wish you luck on the worksheets, but if you need it, I mean, well, I guess I'm there, but I'm just going to probably think a little bit less of you. So yeah, good luck with the worksheets.